There we go. Can you hear me now? Darn this microphone. It knows. It knows that when I'm pressed for time and I don't have time to test it before the stream, that it's going to screw up. Okay, so hello and welcome to Space Week Live with me, Raw Space, on this Sunday, November the 7th, 2021. You know what, let me adjust my brightness a little bit down, because I am quite bright. That's better. Okay. So we had a week full of Chinese space events, but there were scrubs across the board for everybody else. Let's get into it. So last Wednesday, a Long March 2C launched the second pair of Yaogan 32 remote sensing satellites for the Chinese military from Jiuquan Satellite Launch Center in the Gobi Desert of northwest China into a sun-synchronous polar orbit. According to official sources, the satellites, quote-unquote work as part of a constellation for electromagnetic environment detection and related technological tests. Let's check it out. Apparently there's no audio for that one. Or the sound is messing up again. But we've got some views. The video of Chinese launches is hit or miss. We sometimes get it. We normally get video. We don't always get audio. So I'll assume that's what's going on here. I guess we'll see with the next clip. If there's no audio, then I have something to fix. Look at this, a drone cam. Nice. Here's some... I was going to give you some sound effects, but that last clip had sound on it. So 2 days later, on Friday, a Long March 6 launched SDG-SAT-1 from Taiyuan Satellite Launch Center, 1,000 kilometers to the east of Jiuquan. Also known as Sustainable Development Science Satellite 1, or Guangmu Earth Science Satellite. Its goal is to assess the environmental impacts of human activities. On board are 3 sensors: thermal infrared, low light, and multispectral. With a field of view of 300 kilometers, it can cover the whole globe every 11 days. Nice sound on that one. It's a rather stout-looking rocket. Then on Saturday, a Long March 2D launched the first 3 Yaogan 35 satellites from scenic Xichang Satellite Launch Center, 1,500 kilometers to the south of those other launch sites. According to official sources, these satellites will be mainly used in scientific experiments, land and resource surveys, agricultural production estimates, and disaster prevention and mitigation. That's sort of the pantheon of Earth observation satellite purposes that most low orbit sats are used for, or most sun synchronous polar orbiting sats are used for. All right.
5、4、3、2、1，点火！点火！
I like that very clear interstage between first and second stages that you can see right through it. Whereas a lot of rockets are basically, animations, are basically, they appear to be a solid cylinder, not a solid cylinder, but an unbroken cylinder. Whereas this one has that scaffolding in between the stages. All right. Finally, earlier today, there was a 6-hour spacewalk up at the Chinese space station. They marked a new milestone as taikonaut Wang Yaping became the first Chinese woman to perform a spacewalk ever. Her EVA partner was Shenzhou 13 Commander Zhai Zhigang.
曙光明白，栋梁，你感觉怎么样？
栋梁感觉良好。
曙光明白。
waving to the camera. Let's see. Now for Scrubvember. Not Scrubtember, but Scrubvember. The Japanese Epsilon rocket was supposed to launch Raise 2 yesterday, but it was delayed for the third time. Astra's Rocket 3 was supposed to launch, but that was delayed again, presumably so they could keep working on the range improvements they talked about previously. The 4 Crew 2 astronauts were supposed to be returning to Earth right now, as we speak, but their undocking was delayed until tomorrow. And the launch of Crew 3 was delayed multiple times, first due to weather, then due to a minor medical issue with one of the crew members that was neither an emergency nor COVID-related, then delayed again, presumably due to weather in the recovery area. So a whole bunch of scrubs, but we're gonna get caught up on that here pretty soon. Now, let's see. In the not a scrub but kind of a scrub category, Blue Origin has officially lost their lawsuit against SpaceX for NASA's awarding of the Human Landing System contract. As you may recall, back in April, 3 companies were awarded study contracts by NASA to flesh out their HLS lander designs. Blue Origin and the so-called National Team with their Blue Moon lander, Dynetics and their team of 25 subcontractors, including Sierra Nevada Corporation, and SpaceX with the Starship HLS edition. Blue was awarded $579 million, Dynetics $253 million, and SpaceX just $135 million. Despite receiving the least study contract money, NASA ended up awarding SpaceX with the HLS contract. This irked Blue Origin and Dynetics, so in early May they filed protests with the Government Accountability Office and with NASA, and they sued SpaceX. Fast forward a few months, and they lost. And so now it's time to move on and hopefully start getting some forward momentum on HLS again. So let's close that sordid chapter of the Artemis saga. Finally, last night at 2 a.m., daylight saving time ended here in the United States. Spring ahead, fall behind, as they say. Eastern Daylight Time became Eastern Standard Time. 2 a.m. became 1 a.m. again, and most people got an extra hour of sleep. Unfortunately, I woke up early and then panicked because I thought that I was about to be late for the Crew 2 undocking stream, which had been delayed anyway, which I found out soon thereafter. Looking ahead to this week, unless there are more scrubs, we have a lot of live stream catching up to do. Let's see. On Monday, November 8th, where is it? Monday. Oh, it's right up here. All right. I'm stupid. On Monday, November 8th at 11:45 a.m. Eastern, 16:45 GMT, begins 35-hour continuous coverage of the return of the Crew 2 crew on Crew Dragon. Astronauts Shane Kimbrough, Megan MacArthur, Aki Hoshide from Japan, and Thomas Pesquet from France launched to the ISS aboard SpaceX Crew Dragon Endeavour back on 23 April. 199 days later, they will undock, deorbit, and splash down off the Florida coast. Undocking is scheduled for 2:05 p.m. Eastern, 19:05 GMT. Splashdown is 32 and a half hours later at 10:33 p.m. Eastern on the 9th, or 03:33 GMT on the 10th. Those day splits between time zones really get cumbersome to announce, but I use Eastern time for my American compatriots and GMT for the rest of the world. So I could also list local time at the launch site, but I mean at the, well, this is a splashdown. But anyway, local time on ISS is GMT, UTC anyway. So now, while that I wanted to mention, I've heard some noises that the toilet on Crew 2, the Crew 2 Crew Dragon, is non-functional, so that crew will need to hold it for 35 hours or 32 hours. And additionally, they have diapers that they'll be wearing if they can't manage to hold it. But if I were one of them, I would probably try not to drink too much beforehand. C'est la vie. The life of an astronaut is certainly not all glamour, as they learn. I'm sure they learn before they even get up there, but certainly once they get up there, they realize that it's not all glitz and glamour. All right, so while that live stream is still going on, at 7:51 p.m. Eastern on Monday, or 0:51 GMT on Tuesday, Japan plans to launch their Epsilon rocket with the Rapid Innovative Payload Demonstration Satellite 2, or RAISE-2, which is a tech demo for JAXA plus 8 smallsat rideshares. 4 hours later, also during the marathon livestream, on Tuesday, November 9th at midnight Eastern, 0500 GMT, an Astro Rocket 3 might be launching from Kodiak Island, Alaska, if their aforementioned range improvements are complete. They have a 3.5-hour launch window. And this is with the non-deployable test payload for the U.S. Space Force. Then on Wednesday, December 10th, nope, this one up here, at 4:15 p.m. Eastern, 21:15 GMT, we have yet another 29-hour continuous coverage marathon stream of the launch through docking of Crew 3, with NASA astronauts Rajachari and Thomas Marshburn, ESA astronaut Matthias Maurer, and NASA mission specialist Kay LeBaron on their SpaceX Crew Dragon Endurance, a brand new vehicle that has never flown before. I will open the stream with 30 minutes of Q&A and then hand over the reins to the very capable NASA and SpaceX. Launch is scheduled for 9:03 p.m. Eastern on the 10th, or 02:03 GMT on the 11th. Docking is 22 hours later at 7:10 p.m. Eastern on the 11th, or 0:10 GMT on the 12th. Coverage will continue through hatch opening and the welcoming ceremony for a couple of hours after that. While that live stream is going on, this is going to be a big cluster, massive of streams, I swear. While that live stream is going on, at 11:25 p.m. Eastern on the 10th, 4:25 GMT on the 11th, a Rocket Lab Electron rocket will launch the Love at First Insight mission with a pair of satellites for Black Sky Global's fleet. Finally, on Friday, November 12th at 6:16 a.m. Eastern, 11:16 GMT, a Falcon 9 will launch Starlink 31 4-1. So these are a new version of Starlink satellites, production version with the laser interlinks from Cape Canaveral. I'm not sure if there will be 60 like previously, or I'm not sure if the laser interlink systems change the Starlink dimensions such that they can no longer fit 60 on a stack, but I guess we shall see. They'll tell us at that time. So it is shaping up to be a crazy streaming week, and I hope that you join us here for it. I'd like to take a moment to extend a special thanks to our longtime channel contributor Alecs in the UK, that's ALECS, for his continuing generous support. If you enjoy space content and you value the services that this channel provides, the live streams, SpaceWeek, science advocacy, engaging chat community, and so on, there are a number of ways you can help. Of course, make sure to like, subscribe, and activate notifications. That's all free, and it feeds the YouTube algorithm, ever-hungry algorithm, so that more people can find this place. Now, oh, where did my thing go? Okay. If you like merch, such as t-shirts and mugs, the Rawmart merch store is always open. There are currently 3 designs available: the Raw Space logo, Space Steak, and t-shirts with Bennu on the front and the Raw Space logo on the back. Unfortunately, my signature Yin Yang Planets design and my Bennu only design are currently on hold while I fight with Teespring about warrantless copyright takedowns. They took down my design of a picture of my own cat because they thought it was copyrighted by, I have no idea. They're on crack, but hopefully I get all that worked out. Or say Fooey on Teespring, I'm going to go with a different merch vendor that it isn't so Nazi and stupid. On that happy note, by clicking the join button to become a channel member for as little as $1.99 per month, you get a cool green name, membership icon, access to custom emojis such as Bennu and Starman, and you're immune to slow mode during busy live streams. The contribution options here on YouTube are great, but not everyone knows that YouTube actually takes a 30% cut. That's right, YouTube gets 30 cents out of every dollar from channel memberships, super chats, and super stickers, as well as advertising revenue. That's why I also have a Patreon at patreon.com/rawspace. Even Patreon takes a 5% cut, but that's still a far sight better than 30%. The most direct way to donate is via PayPal at paypal.me/rawspacevideos. Just make sure to change from paying for an item or service to sending to a friend during checkout, and PayPal will take a 0% cut. All that is optional, of course, only for those of you who wish to help out. I don't believe in providing different levels of service for different... I want everybody to have access to all the same content, so I don't have any restrictions on any of that. So if you don't contribute, that is perfectly fine. Just come here and enjoy the streams and whatnot, and that'll be good. But YouTube is my passionate hobby, not my job, though it certainly takes up a big chunk of my time and energy. I don't actually earn a lot of money from the channel. For one thing, most of my streams are not monetized, but it is enough to cover my Starlink internet service and occasional upgrades to my computer and other gear that I use to produce and provide content to the channel. Anyway, thank you all for your presence and your continuing support. Now it is time for your questions. Your questions. Let's see what you got. We have a few. Iwo Wisniewski. What's the difference between Lions and Spakowski? No, that's not the question. What's the difference between Soyuz 2.1A and 2.1B and 2.1V? Off the top of my head, I couldn't tell you the difference between 2.1A and B. If I recall correctly, the V variant is the Soyuz with no side boosters. That's just the core stage with no Korolev cross boosters on the side. And as far as A and B, I am not actually sure. I know that the crewed Soyuz vehicles launch with a Soyuz 2.1A, I believe it is, and then the B is usually used for satellite launches. Maybe it simply has to do with the upper stage. I'm not sure. I'm sure that someone in the chat will clarify. Snow Kittens, are you around? And Iwo Wisniewski again. Where does Sci News get all the videos? Yeah, so Sci News is a Romanian-based or a Romania-based channel that somehow manages to get internal, like, straight from CNSA videos of Chinese launches very soon after they happen. Now, these launches are not live streamed that I'm aware of, even in China. I don't know, maybe they are live streamed in China. I don't have access to that. But somehow they do. And so I am not sure. There are sources for launch videos from China, but they don't make it easy. So, I mean, because we're not their primary audience. They have, 1.5 billion people or whatever that can consume their launch content without having to bother with the rest of us dregs. So I'm kidding. So I'm not sure where they get their videos. I would actually love to have some more reliable and convenient sources for some of the Chinese launches. But usually it's Sci News is where I have to go for those, because they have their wherever they get them from, and that works. So plus, they don't do live streams, whereas I focus primarily on the live streamed launches. Iwo Wizanowski again. Is the Long March 6 solid or liquid? Most of the Chinese rockets are hypergolic. Most of the Chinese rockets use nitrogen tetroxide and unsymmetrical dimethylhydrazine, or UDMH, hypergolic fuels, which are liquid hypergolic fuels. And so the orange puff that you see coming out of a lot of Chinese rockets that is the nitrogen tetroxide, which is very unfriendly stuff to the human respiratory system. But it is very convenient because it doesn't need to be stored cryogenically, and it can be basically stored at room temperature, or just a little under, until launch time, and then they mix the fuels and boof, they have thrust. Another question from Iwo. When the Russians spacewalk from the Poisk module, is it depressurized? So, excuse me. So Poisk is one of the Russian modules on the ISS, and Poisk itself does not depressurize. They have an airlock that they used to use. What was it? Shame on me. Just a few months ago, Pirs docking compartment. Yes, the Pirs docking compartment, PIRS, or whatever Russian characters that constitutes. They removed Pirs in preparation for the arrival of Nauka, and but now they have what are they using Nauka, or do they have a different airlock? I'm not sure, but in any case, they have an airlock that depressurizes prior to doing an EVA. Shannon Woods, hello Raw Space, hello to you. It takes a whole day to get home. Yes, the way they have it planned out, it takes. I think they did have the schedule a little tighter on a previous scheduled attempt, but they had some delays due to I guess weather on the return of the Crew 2 crew, and it takes quite a while to get back from the ISS to Florida. It's quicker to get back to Baikonur, or not to Baikonur, but to Zhezkazgan, or to Kazakhstan, middle of nowhere Kazakhstan, near Zhezkazgan, because the ISS's orbital inclination is optimized for that site. It is not optimized for Florida. And one day I will have a better answer for you on why that is. But it will probably get fairly technical, so I'll have to do a lot of homework for that one. Crystallina bacteria, what do you think of radio signals from space? I think they're awesome and fascinating. Of course, you've got pulsars, you've got, neutron stars and magnetars and black holes, and you've got, even just regular stars. You've got whole galaxies that are spewing out radio signals across the spectrum in all sorts of different ways. And sometimes occasionally we'll receive a signal that's particularly strong, or that's particularly atypical or unusual, and we will investigate it, look into it further. A lot of times signals aren't detected for some period of time after we've received them, sometimes even years after, when a scientist or even a community, a citizen scientist will go back and crunch data from the past and discover things. That's also how we discover a lot of exoplanets, is by going back to old data and reanalyzing it. As for whether signals from space represent little green men or not, that remains to be seen. The vast majority of signals can be explained in purely natural, or from purely natural sources, but that's not to say that there aren't also alien signals out there. But to my knowledge, we've never encountered anything that was. There are signals, just like there are unidentified flying objects that we don't necessarily have an explanation for, but there are always plausible explanations that can be offered. But we don't know what everything is. That's why we have science, because we need to observe and test and hypothesize, experiment and observe some more, and use our craniums to analyze data, and we get closer and closer to understanding what's really going on. But let's see, crystallina bacteria, is there an asteroid as big as the Eiffel Tower hitting the Earth? No, there is not. I think the closest approach from an asteroid, from a sizable asteroid, is Apophis, which is going to pass by us in a few years, I guess. What is it, 2027 or something like that? But it's, they've determined that it's going to miss us by, I think 16,000 miles or something like that. Very, very close, cosmically speaking, but still, not at this point, it is no longer a risk of impact. Now, there could be smaller rocks that could get past our detection or whatever. I mean, for example, the Chelyabinsk meteor a few years ago that exploded over Chelyabinsk, Russia, was approximately the size of a school bus, like 60 feet long, something like that. And that's pretty big. I mean, that produced that was the second largest asteroid. It wasn't an impact, but asteroid explosion. It was an airburst on record since the Tunguska event of 1906, I believe it was, also in Russia, because Russia's really big. Yeah, that was the biggest asteroid atmospheric event in more than 100 years. And the Eiffel Tower is much bigger than 60 feet. I mean, the Eiffel Tower is, what, 900 feet high or something? I'm sorry, I don't know what that is in meters. But yeah, there's definitely not anything that big that has us in its sights that we are aware of. But an object that big is very likely to be detected very much early, probably years before it impacts, because we're gonna, especially with some of the new mega telescopes that are coming online, the Vera Rubin telescope and other facilities, we're scanning the skies constantly for things moving around. And so, if something is up there, we'll see it, we'll plot its course, and we'll detect it years early, unless it's pretty small. So, MVM Motovlog Music. Raw Space, of all the upcoming launches, which are you most excited for, and is Webb still on track? Of the upcoming launches, I am absolutely the most excited and mortally terrified of the launch of the James Webb Space Telescope on December 18th. And we are still on track for that launch date. So James Webb, if you're not familiar, if you've somehow been living under a rock for the past 20 years, is the next great space telescope. It is an infrared telescope, whereas Hubble was primarily an optical telescope. But it's a multi-billion dollar, like a $20 billion project, spanning more than 20 years of time. It's experienced cost overruns and delays and more delays, technical issues and complications. But we're finally down to the wire, and we're finally looking at a launch on December 18th. And I'm absolutely excited for it, because it will allow us, see, one of the challenges of astronomy is that there's a lot of dust out there that obscures optical light. And the best way to look through dust is in different regions of the electromagnetic spectrum, by looking at different wavelengths, for example, infrared. And, so we've had, Hubble was primarily optical, Chandra, it was an X-ray observatory, James Webb is an infrared observatory. And with it, we will be able to see farther than ever before. Also, consider that as the expansion of the universe progresses, as the universe continues to expand, due to the mysterious phenomenon known as dark energy, which may or may not be a form of energy. We don't know what it is. We just know that the acceleration of the universe appears to be increasing. I mean, the expansion of the universe appears to be increasing, which seems counterintuitive, but reality is what it is, and it doesn't need to conform to our ability to understand it. But as the universe expands, distant galaxies are moving away from us more quickly than nearby galaxies, which results in red shift. The farther away something is, the more the wavelength of that light, and by light I mean the full electromagnetic spectrum, gamma rays, X-rays, radio waves, visible light, infrared, ultraviolet, all the whole spectrum. It's all photons. It's just in different wavelengths. Gets stretched out, and yellows become red, blues become whatever is longer wavelength than blue, orange, blue, orange, whatever. Anyway, as the farther away something is, the more red it gets, which is why when you see like pictures from Hubble of very, very distant galaxies, let's say in the Hubble Deep Field, the most distant are just little red smudges, because of the wavelength of light has been stretched. Now, that stretching, that red shift, actually extends beyond the visible spectrum, look far enough away, and the galaxies are the light from those galaxies has been stretched so much that it is actually in the infrared range, which is outside of the visible range, but still close to red. Go farther, and if there's anything out there, you could actually have galaxies in the radio range of the spectrum, which is really long wavelengths. So those would only be detectable with instruments that can observe in those wavelengths. And so by launching James Webb, we get the premier whiz-bang observatory in the infrared range of the spectrum, which will allow us not just to see finer, not just allow us to see through a lot of that space dust, but also allow us to see galaxies that are farther away than we are even able to see in the optical range of the spectrum because of that redshift effect. So I think that's, and for example, it would allow us to determine whether there is a cosmic horizon. We can't see past the beginning of the universe by looking back in time, but what we can see is, we don't even know how big the universe is. It might go on forever. We have no way to know it because we can't see past a certain point. And hopefully James Webb will allow us to get closer and closer to the beginning of the universe, so that we can, get a better handle on where we come from. It's academic. It doesn't affect our daily lives, but it's why we're here. So it's why everything is here. So it matters. All right, what do we got? So, any more questions? All right, looks like that'll wrap it up for this week. Thank you all for coming. I appreciate it. And if I survive this next few days of streaming, I will see you next week. Same time, 10 minutes earlier, hopefully, and same channel. Until then, keep it raw, and I'll catch you later.